Hey, so we're going to go over multiplying and dividing rational expressions, and we're just going to go over some of the basics so you understand what we're doing. So let's just start with something very straightforward. What if I have 8 divided by 2? Well, I can rewrite this as 8 over 2. I could also write this as 8 over 1 times 1 over 2. Okay, so I've kind of just made a pattern here that if I just flip this sign, I could divide it. So that's kind of nice. So I will now do this. I say 8 divided by 2 is the same as 8 times 1/2. So what if I had something a little bit different? 3 over 2 divided by 1 over 6. But I know if I just change the symbol, I flip the ratio. So that's the same as 2 over 3 times 6 over 1, which is the same as 2 times 6 over 3 times 1, and that's 12 over 3, which equals 4. Okay, so these are sort of the mechanics of how we operate with the rationals. So now let's go to something a little bit more complicated here. Okay, so I'm going to factor this. I'm also going to flip this sign in the ratio. I have x minus 3, and now I have times x over, and if I factor that, that's going to be x minus 3, x plus 3. Okay, so this then equals x bracket x minus 3 all over x minus 3, x plus 3. So I can cancel this out, and then I have x over x plus 3. So this is our simplified form, so we've gone and simplified things, but we need to make sure that the restriction's still upheld. So what we could do here is I'm going to say x plus 3 can't equal 0, which is the same as x can't equal negative 3. But we also canceled out this, so I know that x minus 3 can't equal 0, which is the same as x can't equal positive 3. But what about this one? So it's now in the numerator, but it started in the denominator, so it also can't equal 0. So x can't equal 0. So now I have these three conditions, plus 3 and minus 3. So x can't equal any of those numbers, and we have this rational function, rational expression. An expression just doesn't equate to something. It just is the expression of it. Okay, so we're going to do one more. So this one's a little bit more complicated. So I have x squared minus 4 over x squared minus 4x divided by x squared minus 3x minus 10 all over x squared minus 11x plus 28. Okay, so this is where we're going to start with. We're going to flip this sign, and we're also going to factor it. So let's factor the top. You get x minus 2, x plus 2, all over x bracket x minus 4. Now if we divided this, we'll have x plus 2, x minus 5. And here, we factor this, we get x minus 4, x minus 7. So if you need help factoring, go to a factoring video, and I've made some. They're very straightforward, but what we're trying to do here is, for this term, two things that multiply to positive 28, which is negative 4 and negative 7, and two things that add to negative 11, so negative 4 and negative 7. Okay, now we're going to flip this. Okay, so now we can simplify. So what we have is x minus 7, x minus 2, x, and x minus 5. Okay, so we've gone through. This is as simple as it's going to get, but we have to go through and make our conditions that the denominator cannot be 0. So we have quite a few here. We had this one, so let's start here. X can't equal 0. And the next one was x minus 5 can't equal 0, which is x can't equal 5. Now we had another one that we canceled, the x plus 2. And we have this, the x minus 4. And we also had some other ones. The minus 4 was here, and the 7. See, x minus 7 was in the denominator to begin with. We also have x minus 7 can't equal 0, which is x can't equal positive 7. So our whole set is, if we do the denominator, the domain, is the domain of x such that x is an element of a real number, that's our fancy R, but x cannot equal 0, 5, -2, -4, and 7. And we close the bracket. So that's how we multiply and divide rational expressions.